Hi, welcome to Varenia's Photon Online Educational Academy. This is Guntuka Srinivas. It is a free online educational channel meant for 8th class standard to the 12th class standard students. In the previous session, we have seen some problems related to the distance and displacement concepts. Let us see some more problems in this regard. Let me take up the first problem. A farmer moves along the boundary of square field of 20 meters side in 40 seconds. The 40 seconds. What is the distance traveled? What is the distance traveled in moving once around the field, This was the first question given. Observe carefully. What he is asking? A farmer is having a square field of 20 meters side. He moves along the boundary of the square field in the 40 seconds. Now, in the question, what is asking? What is the distance? What is the distance traveled in moving only once around the field? This was the first part of the question. Observe. There is a second part of the question also. That second part of the question is the magnitude of what is the magnitude of displacement at the end of 2 minutes 20 seconds. 2 minutes 20 seconds. That was the second part of the question. Second part of the question. Yeah. Now, how the clarity is asking magnitude of displacement at the end, not one round. At the end of the how much? 2 minutes 20 seconds. See the clarity in the question. First, what he has asked? He has asked for distance. Distance only once around the field. That's all. But displacement is asking displacement at the end of the 2 minutes 20 seconds. Have the clarity, the difference between distance and displacement asked. Okay. Now, let us solve this problem. Clear? Let us say this is the square field. This is the square square field of the farmer. So what is the side of the square field? It says, let us say A, B, C, D is the square field. Here I write clearly, square field it is. Clear? Now the side of the square field is 20 meters. All are same side, 20 meters. 20 meters. Yeah. Now, what it says, the farmer moves. Let us say that farmer is starting at A initial point. He moves along the complete boundary of the square field like this. Only once he moves. A to B, B to C, C to D, and D to A. Complete boundary of the square field once he moves. In that case, what is the distance he says? In that case, the first case is distance. Distance. Once around the boundary of field. Boundary of the field. Only once around the boundary of the field. Now, this is A to B path length, B to C, C to D path length, D to A. That means total distance is how much? AB plus BC plus CD plus D. So completely 20 plus 20 plus 20 plus 20. All are 20, 20. So 80 meters. Complete distance traveled here it is. Distance traveled, complete path length once 80 meters. Yeah. Now, the second part of the question. The second part of the question B, displacement. Displacement. Magnitude is asking. Clear? When at the end of 2 minutes 20 seconds. This is the time. 2 minutes 20 seconds. Now let me convert the entire time in the seconds. 2 into 1 minute is 60 seconds. 60 seconds plus adding these 20 seconds. Complete 120 plus 20, 140 seconds. That means displacement at the end of the 140 seconds we need. Clear? Displacement at the end of the 140 seconds we need. Observe here. Now, what he says in the problem that farmer completes one round, complete round, one round of the field. In how many seconds he completes? In 40 seconds. He says that farmer is completely, observe, this is the field. This is the field A, B, C, D. So all are 20 meters, 20 meters, 20 meters, 20 meters. So completely, if he is starting from A, complete A to B, B to C, C to D, D to A, complete one round, he completes in 40 seconds. But displacement is asked at after how many seconds? 140 seconds. 2 minutes, 20 seconds, 140 seconds. So in 40 seconds, how many rounds is completing? In 40 seconds, he is completing one round. One round around. So what we require is in 140 seconds, how many rounds? How many rounds? How many rounds he completes? How many rounds he completes? For this, Simply here 140 seconds by 40 seconds. If I simplify, 0, 0 goes out. So 2 2s are 2 7s are completely. So 3.5 rounds. How many rounds? 3.5 rounds. In 140 seconds, he completes 3.5 rounds. Yeah, 3.5 rounds. Now that is the conclusion, because we require at the end of the 140 seconds, if he completes one round in 40 seconds, in 140 seconds, how many rounds? 140 seconds divided by 40 seconds. So 3.5 rounds he completes. That means we require displacement at the end of the 3.5 rounds. Clear? That is our conclusion. Okay. Now come to the field. This is the field, square field. A, B, C, D. All are 20 meters, 20 meter side, 20 square feet, 20 meter, 20 meter. Now, at the end of 3.5 rounds, 3.5, 3.5 rounds, we require displacement. We want displacement. Clear? Okay. Now, if the farmer is starting from A to B, B to C, C to D, and D to A, one round. Again, second round, A to B, B to C, C to D, D to A. Again, third round. Finally reaches A. 3 rounds he completes. Then off round. That means A to B, E to C. Only this part he completes. He reaches finally 3.5 means once, twice, thrice. At the end of third round, it comes to initial point A, then AB, BC, because only off. Remaining CD, DA, it will not go. Only off AB and BC. That means final point is where? Final point is C. That means A is initial point, initial position. C is final position. Final position. Clear? Now, what is the displacement? Displacement is nothing but the shortest distance between the initial and final. So, A to C. A to C, the displacement, shortest distance between the initial and final, or simply the length of the straight line joining the initial position to the final position, AC. Complete 3.5 rounds, finally reaches C. Initial point was A to C. Clear? Now, to find out AC, observe this. ABC is a right angle triangle. We require hypotenuse. So, in right angle triangle, ABC, okay, AC square is equal to, hypotenuse square is equal to base square plus height square. Clear? That means BC square plus AB square. So AC square is equal to BC is how much? 20. 20 square plus AB is how much? 20 square. That means 400 plus 400 is 2 into 400, 800 AC square. Now, what is AC? AC, we require displacement. Square root of 2 into 400. That means 20, 400 square root is 20, 20 root 2 meters. This is AC 20 root 2 meters. Yeah, that is the displacement. And what is the direction of the displacement? You know very well. From the initial position to the final position. That means what is the direction? The direction is from A to C, initial to final. Yeah. Even if you want the direction in terms of theta, you can simply say that displacement vector AC is making some angle theta with the AD horizontal. Then in this ACD triangle, tan theta is opposite side CD by adjacent side AD. So opposite side CD is 20 and adjacent is also 20. So in ACD, right angle triangle, the tan theta is 20 meters opposite side by 20 meters adjacent side. So it becomes 1. So tan theta is 1, theta is 45 degrees with respect to horizontal AD. Here, this is the direction of displacement vector AC bar. Direction of displacement vector. Here, these are the solutions. Let me take up the second problem. Here, let me take up the second problem. The second problem, here I got that the length of minutes hand is 14 centimeters in a clock. Find the distance and displacement in. He has given the 4 cases. First case he has given 60 minutes. In 60 minutes. Second case he has given 30 minutes. Third case he has given 15 minutes. Fourth case he has given 10 minutes. In all the 4 cases, he needs distance as well as displacement. Observe carefully. Length of minutes hand 14 centimeters in the clock. He requires distance as well as displacement in all the 4 cases. Okay, let me take up this problem. First, let me draw a clock. This is a clock. This is the center of. I am dividing the clock in the 4 quarters. These are the 4 quarters. Here, this is initial position. Initial position is, let us say A amp. Clear? This is B, 1 quarter B, 3rd quarter C, 4th quarter is D. Here, now observe carefully. In this case, here initially A is 0 minutes. This is 5 minutes. This is 10 minutes. This is 15 minutes. This is 20 minutes. 25 minutes. 30 minutes. 35 minutes. 40 minutes. 45 minutes. 50 minutes. 55 minutes. Finally, 60 minutes. This is the clock position. Clear? And observe carefully. This is a minute's hand. This is minute's hand. And if I consider the entire circle, clock as circle, then 0, that is the O is the center of the circle, and the minute's hand as radius R. So the length of the minute's hand, the length of minute's hand is radius is how much given? 14 centimeters. The problem itself given 14 centimeters. If I think entire thing as circle. Clear? That is the circle So the length of the minute stand or radius, that is the sample. Now, what is the question? First question is asking, first question was 60 minutes case. In the 60 minutes case, he says two things. First, he requires distance. Observe. Distance is what? If the minutes hand starts from A, completely moving 60 minutes. 60 minutes moving and finally reaching A. Starting is also A, moving 60 minutes and reaching the A. So completely, what is the total path length? Circumference of the circle. That means distance is 2 pi r. Distance is 2 pi r. Circumference of the circle, that is the path length. So 2 pi. Pi is how much? 22 by 7. The value of pi, 22 by 7. R is radius. Length of the minute stand, 14 centimeters. 14 centimeters. So here, if I simplify, 7 to 0. So completely it becomes 88 centimeters. 88 centimeter distance. Clear? No. What is the displacement? It is starting from initial position A, again completing 60 minutes circle, reaching the final position also A. Complete one round. Same position it is reaching. Displacement is 0. Distance between initial and final, 0. Clear? Shortest distance. That itself is both points are coinciding. So here I say that displacement is 0, 0, null vector. 0 means not simple 0, it is a null vector. Null vector is having 0 magnitude, no specified direction, because initial, final point, both are coinciding. First case is over. Let me take up the second case. Clear? Again, I am drawing the same circle, clock. Clear? Dividing into the 4 parts. 4 corners. Or is it? Okay. So first initial point A, B, C, D, and this is the minutes hand having the radius R. Clear? Now again, in this case, this is 5 minutes, 10 minutes, 5 minutes, 5 minutes, 10 minutes, 15 minutes, 20, 25 in the clock, 30, 35, 40, 45 minutes, 50, 55, finally at A, 60 minutes. This is the clock position. Now, what is the second case? Second case, he says that second case, 30 minutes case. Minute hand is moving 30 minutes. In that case, distance is required. Observe, distance is path length. In this, if minute hand is starting from initial position A, moving 30 minutes like this, 30 minutes is completed C. Initial point is A, 30 minutes is semicircular portion, reaching the C. A, B, C path length. Semicircle. For semicircle, what is circumference? Pi r. Pi r. Clear? Pi value is 22 by 7. R is 14 centimeter. Then simplify this 7 to 0. So 44 centimeter is the distance. Clear? Now, what it requires? It requires, second thing is displacement in this case. Displacement. Displacement it requires. Initial position is A, final position is C. So displacement is the shortest distance between A to C. A to C means connecting A to C. A to C. So this is diameter. Diameter A to C is diameter R plus R. This is R, this is R. So 2R. 2R. 2 into R is 14 centimeters. So it is 28 centimeter distance. Shortest distance between initial and final position. Clear? That is the case. Okay. Now, coming to the third case. Third case is 15 minutes case. 15 minutes case. In the 15 minutes case, first, what he requires? He requires distance. Okay. Distance requires year to year 15 minutes. A to B is 15 minutes. Clear? This is a quarter circle. For complete one circle 2 pi r, and for A to B quarter circle is how much? 2 pi r by 4. So 2 pi r by 4 per quarter circle. So it becomes pi r by 2. Pi r by 2. Already pi r we calculate here 44 centimeters. So 44 by 2. That means 22 centimeters. 22 centimeters. That was the complete distance in the 15 minutes case. A initial point, 15 minutes completing, the minutes hand come to the year B. So A to B. This is the quarter circle, arc length AB. Complete circle is 2 pi r. Only I require AB, quarter circle, arc length AB. So 2 pi r by 4. 1 quarter. Pi r by 2, simplify. Pi r already here we have calculated. Same thing, I am substituting. 44 by 2, 22 centimeters. Now, in the second case, he requires displacement. What is displacement? Shortest distance between A and B. Shortest distance between A and B. This is A and B. So A is initial part, B is final part. Now observe, AOB is a right angle triangle. If this is AO is R radius, OB is also R. AOR, OB is also R. So in the right angle triangle, hypotenuse we require. Just going here, this is the right angle triangle. O, A, this is B. This is complete right angle triangle. So in this case, this is R, this is R. We require the AB. We require AB. So in this right angle triangle, AB square, hypotenuse square is Pythagoras theorem. Base square plus height square. So OB square, base square plus height square, OA square. So R square plus R square. This becomes 2R square. So AB square is 2R square. So AB is square root of 2R square. This becomes root 2 into R. Clear? Root 2 into R. What is R? Root 2. R is how much? Radius of the circle. That means minutes. R is 14 centimeters. 14 centimeters. So 14 root 2 centimeter. 14 root 2. 14 root 2. I'm writing this first, then later this. Centimeter is the displacement. EV is displacement. Shortest distance between initial and the final position. Initial position, final position. In case of 15 minutes, quarter circle. Yes. Is it clear? Now, let me take up the last case. The last case, let me take up. This is the circle. Clear? This is the circle. Okay. This is circle. I am dividing in the 4 quarters. These are the 4 quarters. This is O, clear? O, origin, center of circle. Now, putting the points A, B, C, D. Now, as usual, 5 minutes, 10 minutes, 15 minutes. Likewise, all of this. In the fourth case, what does it require? It requires the fourth case, 10 minutes case. 10 minutes case. In 10 minutes, what is the distance traveled? First one is distance traveled. Distance traveled in 10 minutes is same. That is the first question. Now observe, if I put up, this is the minutes and OA is minutes and having radius R. Clear? After 10 minutes, 5 minutes, initial position is A, 5 minutes and 10 minutes. After 10 minutes, minutes and goes here. This is the minutes and both are having the radius R. Final position is this. Here I am indicating this is the final position. Let us say this is some M. So A is initial position, M is the final position. A here, minutes and is moving 10 minutes. So AM is 10 minutes. 5 minutes, 10 minutes, final position. Now in this case, what is the path length mode? Path length mode is this. AM is the path length. AM is distance. AM, path length. That is the distance. We need the AM. We need AM. Clear? For this case, observe carefully. In one rotation, the minute stand is moving how many minutes? 60 minutes it is moving. In one rotation, minute stand is moving 60 minutes. In the 60 minutes, what is the total path length covered by minute stand? 2 pi r. The entire 60 minutes in one complete rotation, the path length covered by minute stand is 2 pi r. That means in, here I am putting in 60 minutes, in the 60 minutes, minute stand is covering how much path length? 2 pi r. That means complete 2 pi r in the 60 minutes covered. But we require only in 10 minutes. In 10 minutes, what is the path length covered? Very good. So just simplify this. Just simplify this. This is the simplification. Here, 2 pi r into 10 by 60 by 60. 0, 0 goes. Just simplification, pi r by 3. 2, 3, pi r by 3. Clear? Pi r by 3. Pi r already we have calculated earlier case. Pi r is how much? 44. Pi r is 44 centimeter. 44 by 3 centimeter. Simplify. This is the distance traveled. Have the clarity. In complete 60 minutes, the entire path length covered is 2 pi r. But the fourth case, what is asking? Only in 10 minutes. In 10 minutes, what is the path length cover? Distance is nothing but path length. So in 60 minutes, 2 pi r path length. In 10 minutes, how much is the path length? So 2 pi r into 10 divided by 60, 44 by 3 centimeters. That is AM. That is path length. That is nothing but distance. Clear? Now, we require displacement. We require the displacement also. Observe. This is the circle. This is the complete circle. Here I am dividing in the quarters. Four quarters. O center. Let us say this is A position, initial position by minutes. In 10 minutes case, M is the final position. Now, this minute stand initially at A having R. Finally, after completing 5 minutes, 10 minutes, 5 minutes, and 10 minutes. After 10 minutes, it is coming over here. AM is the path length. Just now we calculated the path. Now, what is the displacement? Initial point is this, final point is shortest distance between A and M. That is the distance. AM is the shortest distance, a straight line. Shortest distance between the initial and final, or the length of the straight line joining initial and final position. That we want. This is. To find out AM, we require this theta. We require this theta angle. Clear? Now observe. Complete for the entire complete 360 degree for entire minute stand making complete one rotation. What is the total angle covered? 360 degrees. That means in one round, minute stand completes how many degrees? 360 degrees. Yeah, in complete one round. That means in 60 minutes, what is the angle covered by the minute stand? 360. So in 60 minutes, complete rotation 360 degrees is covered. But we require only in 10 minutes. So in 10 minutes, what is the angle covered? Simply 10 into 360 by 60. So 10 into 360 degrees by 60. So if I simplify this, okay, just 60 degrees. That means theta is equal to 60 degrees. This is 60 degrees. Theta is 60 degrees. Clear? Theta is 60 degrees. In this case, a simple formula is present. If observe here, if this is R, and this is also R, this is the point O, if this is theta, clear? On this initial to final point A to M required, okay? AM is simply given by a simple formula, and that formula is AM is 2R sine theta by 2. In the previous classes, we have seen this. 2R sine theta. 2 into R. R is how much? The length of the minute stand. That is 14 centimeters. And sine theta. Sine theta is how much? Sine 60. Sine 60 degrees by 2. So on simplification, clear? Sine 60 by 2, sine 30. Sine 30 is how much? Half. And this 2 into this half cancels. Final answer is 14 centimeters. So AM is displacement. So in this case, here I write displacement. Displacement is equal to AM. which is equal to 14 centimeters. 14 centimeters. Clear? This is the simple formula, and this formula just you remember it by heart. It you have already derived in the previous classes. Okay, this is the calculate the displacement in the especially circles. In especially circle, AM is done. Clear? So when you solve the problems, be thorough with the concepts. You will get a clarity. Then only you will make good attempt in solving the problems. I stop this session. Thank you very much for your patient listening. If you like the video, please share it and subscribe the channel. Thank you.